This lesson is for Chapter 6, Section 2. Please open up your books to that section, get your notebooks out and ready to go, and we'll get this one started. So on our first section, we talked about graphing and substitution as ways to solve these linear systems. And today we're going to look at elimination as another method. So with the elimination method, what we attempt to do is to create opposites between either our x terms or our y terms in the system that we have. Now you're going to do that by multiplying through your equation by some number that will end up creating those opposites. Once you have the opposites, when we combine them, those are going to cancel out and allow us to solve a one variable equation. Once you have solved one variable in the problem, step number 4 says sub that amount back into one of the original equations and solve for the second variable. All right, so let's put this into practice with a quick review. Checkpoint number 1 on page 434 gives us this system and asks us to solve it with elimination. Now notice that this is kind of an easy one because they already have the opposites in there for us. So using combination, 2x and 2x makes 4x. 4 negative 1 make 3. Dividing both sides by 4, I get x is equal to 3/4. Substituting that x value into either the top or the second equation, we have 2 times 3/4 plus y equals 4. I just picked the top one. 2 times 3/4 is 6/4. Subtract 6/4 or 3/2, whichever you want to use, and solve. Now 3/2 or 6/4 is equal to 1.5, so you can make it into a mixed number and look at it like that. I'm just going to rewrite 4 so that it's in fourths. That's the same as 16/4. Now subtracting my 6, I have 10/4 or 5/2. So my solution looks to be the point 3/4, 5/2. Okay, if we were to take either of those and put them back into the original equation, hopefully they should work out. Here's another system for us to try. Now notice in this one, we don't have opposites yet, but I'm looking at the y terms here and noticing that one is positive and one is negative. So the signs are already opposite. I just need to have the coefficients be opposites. So I'm going to multiply this equation by 3. So I'm going to leave the top one alone. Multiplying the second one by 3 will give me 15x minus 3y is equal to 51. And combining the two, 17x equals 68. Divide both sides by 17. And x, I think, ends up being 4. So we get a nice number for this one. Now taking that 4 and putting it in either of the first two, I'm going to put it in the top one. We can solve for y. So my solution ends up being the point 4, 3. And again, you can check that by putting it back into the original equation. Sometimes our systems are going to have decimals in them. There's two ways that you could go about doing that. You could leave them as decimals. You can still create the opposites. I like removing the decimal places. So every single one of these digits has 2 decimal places. So using the thought that if you do something to an entire equation, you don't change its value, I'm going to multiply both of my lines in my system by 100. So then my first equation ends up being this. My second one ends up being this. And I just find them a lot easier to work with. Now it's up to you whether you want to eliminate the x's or the y's. I'm going to go after the x's this time. So I'm going to multiply my top row by 2. That'll make a 6x there. and I'm going to multiply my other row by a -3, and that'll make a -6 there. So a 2 through the first one gives me this equation. A -3 through the second one gives me this, and then I combine and I end up with -10y is equal to -120. Divide both sides by -10, and y equals 12. Substituting that back in either one, I'll put it in the top one again. I usually do. We get 3x plus 48 equals 75. So 3x ends up equaling 27. Finish solving for x, and we get 9. So our solution point is 9 and 12. When you're writing this solution point, make sure that you pay attention to which of the numbers you got was your x value and your y value. Don't put your ordered pair or your solution point backwards. They have to be in the form xy. Okay, all of those solutions are going to be points that can be plotted. All right. Now, when graphing systems, okay, graphing was a method that we talked about in section 1. When you have a graphing calculator, or when the systems that you have are both linear or not difficult to graph, graphing can tell us a lot of things. So simply putting the two parts of your system on a grid can show us if there are no solutions, one solution, or infinite amount of solutions. So for example, if the lines end up being parallel, okay, two parallel lines have absolutely no intersection point. So if there are no points of intersection between the lines, there can't be any solutions between them either. So parallel lines have no solutions. Sometimes the lines will coincide, or in other words, they'll graph on top of each other, so they are technically the same line. In that kind of a case, every point that's on one line lies on the other line. So there's an infinite amount of solutions in that kind of a system. The third thing that could end up happening is that lines are going to cross or intersect. That one intersection point provides your one solution. So if we were to take a look at this problem, I'm going to try to get my recording thing off my grid. Hang on. If we were to look at this problem, I'm going to rewrite each of these so that they are in y equals mx plus b form, and I can graph them. So on my first equation, I'm going to move the 2x to the other side, and then I'm going to divide by 3. So I have y is equal to 2/3 x plus 2, and now that can be graphed. Remember, the 2 at the end is in the b position. That's your y-intercept. My slope is the coefficient of x. It says it has a rise of 2 and a run of 3. So up 2, right 3, or down 2, left 3. Works that direction too. I'm going to put a bunch on here and attempt to draw a straight line. Not bad. Second one, I'm going to do the same thing. So I'll leave -6y here and move 4x to the other side. Divide by -6. And I get y is equal to positive 2/3 x minus 3/2. So this time my intercept is at -1.5. And I once again have an up 2, right 3 slope. So when the slopes are the same, I end up with these parallel lines. So for this system, there aren't any solutions. All right, they're going to have a lot of story problems in this section again. So I went through and I found one that I never used to like doing. So if everybody would please turn and find problem number 42. It's located towards kind of the bottom of page 443 in the examples. It's one of those cases where you have two airplanes flying in opposite directions and this happens and that happens and whatever. I remember never liking these. So as I've done more of these over the years, I found that they're really not so bad, but you do have to set up a system in order to be able to solve it. So let's do a couple of things. We have two planes going on. So let's let X we're going to let X be the speed of the first plane. Okay, so we're trying to figure out speeds of planes here, so that's obviously what our variables are going to need to be. We'll let Y end up being the speed, try that again, of the second plane. Now tell me something about those speeds. Okay, so the second plane's speed is 80 kilometers per hour faster. So here's a possible equation. If you had Y's, or the speed of the second plane, subtracting the speed of the first, if it was 80 faster, you should end up with 80 when you subtract their speeds. Okay, there's a different variety of ways that you could write that equation as well. You know, you could do Y minus 80 is equal to X. You could do X plus 80 is equal to Y. But with this one written the way it is, I have both of my variables on the left-hand side. If you went with one of the other ones, you could just move the variables later to get X and Y both on the same side. Okay? Next equation, the other information that we know about this is that the one plane is flying for 2 hours. Okay, and the other one started a half hour after the first. Okay, so if the one went for 2 hours and the other one went a half hour less than that, the other went for 3.5 hours. So this one went for 2 minutes, or 2 hours. This one had to have gone for 3/2 of an hour. Okay, so all that information is in the story problem. That second plane left a half hour after the first, it's right here. So instead of 2 hours, it flew for 3/2 of an hour. All right, so we all know how speed goes. That first plane, if it went for 2 hours at X of a speed, it got that far. The second plane had a speed of Y and it went for 3.5 hours. So I can calculate that distance with 3/2 times its speed. And the problem tells us they eventually got to be 3,200 kilometers apart. So if you took their speed times time and added them together, you'd have that total distance. Okay, distance is equal to rate times time. And if they got 3,200 kilometers apart, we'd add their two distances together to get that far. All right, so we have our second one. Now I'm going to rearrange the first one so that my x's line up. All right, so I'm going to put the negative x here and my plus y here and the 80 back here. When I look at this one, I see that my x's have opposite signs already. So I'm going to multiply my second equation by 2. So I'll leave the first one. And you could have gotten rid of the y's, or you could have done even a substitution method on this one if you wanted to. I like this method best. So my second equation, when I send the 2 through, gives me this. So elimination method. 3/2 plus 4/2 is 7/2 y. And adding these together, we have, what, 3,360. Now, you have to divide off that 7/2. Remember that dividing by a fraction is multiplying by its reciprocal. So I'm going to multiply by that reciprocal on both sides. So y ends up equaling 960, I believe. Then once I have that one, I can come back here, put it in. Either one. This one had smaller numbers, so I went with the second equation this time. And I'm going to have negative x equals negative 880, or x is equal to positive 880. Okay, so the speeds for the two planes, here's the first plane, and there's the second plane. Okay, all right. Do lots of these, especially focus on the story problems. I don't think you guys have a whole lot of trouble solving the systems themselves when they just hand you the equations, but make sure that you can do a few of them. But do take some time to go through a few of those story problems. Okay, I think there was another airplane speed one, number 41. Look to figure out how to set up those systems and give those solutions a try.